Welcome to Stemiverse podcast episode 40. In this episode, Peter and Marcus talk with Dr. Keay. Dr. Keay is recognized as Superstar of STEM by Science and Technology Australia. Sue is a trained scientist with highly developed business skills. She runs the world's first Robotic Vision research centre. The Australian Centre for Robotic Vision, headquartered in Brisbane, is an ARC Centre of Excellence with more than 100 researchers distributed across Australian and overseas research institutions. The centre's mission is to create robots that see and understand their environment so that we can finally reach the tipping point where robots can assume capabilities that have previously only been imagined. Sue recently developed a successful $1.5 million research and development project supported by the Queensland government to explore the vision capabilities of Softbank's social robot, Pepper. Keen to make sure that women contribute to the development of the technologies of the future, Sue believes that everyone can be a roboticist and that science should be accessible to everyone. This is Stemiverse podcast episode 40. Stemiverse is a podcast produced by Tech Explorations. Our mission is to help educators become awesome at teaching STEM, be it at home or in the classroom. Whether you are a professional or casual teacher teaching in a classroom or a parent or caretaker teaching at home, this podcast brings you the knowledge and experiences of practitioners, academics, entrepreneurs, and lifelong learners who are passionate about education and strive every day to help our children prepare for a life in a world of radical change. And why not abundance?
This podcast is brought to you by Tech Explorations, a leading provider of educational resources for makers, STEM students, and teachers. For a limited time only, go to texplore.com/Stemiverse and receive Peter's latest ebook, Maker Education Revolution, a book about how making is changing the way that people learn and teach in the 21st century.
Marcus, how are you?
Good, and yourself?
Not bad, not bad. Do you like my new backdrop, by the way?
It looks fantastic.
Yeah, we are in the
I'm sure
Tech
everybody
Explorations.
agrees.
I'm going to post a picture about that. We are in the Tech Explorations lab, which is now a studio, and I've got a huge backdrop. It takes up most of the room, and some of that actually is sort of hanging. And actually, I like how it looks.
I'm just turning off my phone. I should have done this much earlier.
Bad boy.
Yes. Okay, done.
Okay, right. So today we have a special guest. It is Sue Keay. I should call you Dr. Keay. Is that right, Sue?
Yes, I have a PhD, but that makes me feel quite old if you use the doctor.
We'll call you Sue from now on, if that's okay.
All right, yeah, thanks.
I'd like to begin this interview by asking you to take a few minutes and tell us a little bit about yourself. You can go as far back as you like in life. I know when you were a baby and growing up, maybe tell us a bit about your family, if you think that is interesting in terms of how you got to where you are today. But I'm particularly interested to know what you're doing now in the various roles that you have.
Well, at the moment, I'm running the world's first Robotic Vision Centre, which it's a combination of putting computer vision up and applying it to robotics. Why that's important is that in a lot of the world at the moment, wherever we have robots, they're really only very good at operating in structured environments like you might find in a factory. But for robots to be truly useful to the point where we can have self-driving cars on our roads, we really need for robots to see the world much more like humans do. So we need to improve their vision, and that's exactly what our centre's aiming to do. So we're very fortunate to have that ability to be able to explore this in Australia, and we're really leading the world. So it's very exciting times, and it's been just a pleasure since the centre started in 2014, seeing how these technologies have been developing and how the world's been changing so rapidly over such a short period of time. But I guess a lot of people wonder how I am in robotics when actually my background is quite varied, as you might have mentioned earlier.
Yes, because you studied in science, I believe chemistry, is that correct?
Yeah, my specialty was in earth sciences and I guess applying chemistry. So I would hate to call myself a chemist because I'm sure a proper chemist would think that geochemists don't really count. But my specialty was in using isotopes to work out the age of rocks. And I really loved that part of my life. It was, I loved geology and understanding how the world worked and being able to have that insight into the age of rocks and the timing over which different geological processes operated. I've really enjoyed doing all of that. It gives you an insight into the natural world that I think makes it a little bit brighter every time you go outside and you can apply that knowledge to what you see.
So how are some of the, I suppose, projects, call like that, or projects or practical circumstances where you applied rock age techniques? I imagine things like fossils, right? Trying to figure out how all this piece of rock in which a paleontologist found a tooth from.
I should probably ask, what timescales did you work at?
Yeah, I didn't work over timescales that were probably of too much use for comparing with fossils. A lot of the rocks that I worked on, particularly in Australia, were several 100 million years old. I guess what it was applied to more than actually trying to date life activity was more about understanding how the world works, and that has implications in terms of how you would know where you might find economic ore deposits, for example. But one of the real challenges that still exists in earth sciences is that we're looking at things that have happened in the past that we can't examine easily at the moment because they happen over such long time frames. So what we were trying to do was get some sense of the timescale over which things like mountain ranges formed. Because, there are two schools of thought on that. Are they formed over enormous, lengths of time, maybe 100 million years, or were they formed in catastrophic episodes? And depending on which of those things is correct, can have significant implications for how you might interpret where you find economic ore deposits, where you might expect to find all sorts of different things.
So that's how you link that detective work where you're trying to unravel the past with today's economic activity where with an interesting ore deposit.
Well, yes, and I guess it gives you a bit of an insight into what the future might be like. You might have heard people sometimes are talking about the risk of these supervolcanoes, and to have some understanding of how those events happen and what they might mean is important in terms of how we monitor the situation in the world's volcanoes today.
Right, yeah. That's very interesting. I say that because I see a lot of similar kind of activity in space exploration as well. And I read magazines talking about spaceship going to Io, for example, in Europa, and even Mars and places like that. And a lot of the science that is being developed on Earth, geoscience, is applicable to outside worlds as well. So science is a continuum, isn't it? It's not a set of silos, but it seems to be connected, different branches of science.
So how did you go from geochemist to, I guess, robot vision woman?
Sorry, Marcus, I'd like to go a little bit further back because I want to know where or how perhaps your interest in science began. So can you remember yourself further back when you were a child? What was your relation with science, engineering in general, perhaps the natural world? Can you see some aspects of that led you into eventually getting a PhD on the topic?
Oh, I never thought I was going to be going into science. That was quite a surprise to me. And I guess I probably could say I still don't really know where I'm going. And I've resigned myself to that not being a bad thing. I think there are a lot of people very much like me. And I think the good thing about that is that it keeps your options well and truly open. I guess I've always had a strong belief that I'm a pretty useful person. And if I put my mind to it, I can be pretty useful in a whole range of different areas, and why necessarily restrict myself to one thing. But when I was a child, I guess I probably was quite curious about things. My dad was a physics professor and my mum was a librarian, and I guess we were a family of early adopters. My mum taught herself how to code in COBOL, which was the programming language created by Grace Hopper. And She did this because she was looking at ways that she could improve the business processes at the library that she worked at. So I think she was pretty ahead of her time in that respect. We were...
Did she use YouTube to learn?
No.
Well, I guess this is where I'm going to really show my age. This was, of course, before YouTube. How old are you, Marcus?
It was a time. How old?
No, we are joking. I was learning Pascal from a textbook, and the only textbook that had manual for the language. So yeah, we like to joke about these things. As we do have an audience that is much younger. I did an interview, sorry to interrupt your thought, Sue. I did an interview yesterday and I had to explain what a VCI is to my interviewer.
Oh, that was newfangled technology back in my day.
Exactly. No, I remember when it came out.
Betamax or VHS?
VHS.
Okay.
Sorry, so go on.
Yeah, well, we were a family of early adopters, so we had beta rather than VHS.
Awesome.
Which is a joke that probably only older listeners will appreciate.
We get it.
But so we were one of the first, families, I guess, to have a personal computer, and my dad was always putting new programs on it, and I think at that time when I was at university, they were making that transition from accepting handwritten essays to actually being able to print things from a computer and hand them in. So we were, I guess, always used to having those new things around. And for that reason, I guess I've always had an interest in technology. And I guess I've had a pretty privileged upbringing in that respect, because I was lucky enough to grow up in a household where we had sufficient money to explore some of those things. And I think it's been a bit of a fascination ever since.
Yeah. That's awesome. Marcus, you want to take it further?
No, that's a great job.
So now I want to know what the connection is, or what happened in between you being somebody that understands the physics behind rock aging and works with radioactive materials to try to identify how old a piece of rock is, and with doing what you're doing now, which is you are a leader of a technology that is rather disruptive. We see the applications of computer vision and robotic vision coming online. Mm-hmm. Tesla cars, for example.
Not Uber.
They need a software upgrade.
Yeah, definitely.
Could you bridge that, Sue? Tell us how it happened.
It's been a long path. It might sound like it was just a jump straight from geochemistry into robotics, but that's not exactly the way that it happened. So after I had specialised in geochemistry, I actually found that I didn't really enjoy working in the lab very much. I was much more of an outdoors, speaking to other people type of person, and I was finding the work that I was doing quite isolating, and I made a decision to step out of my research career. But I didn't want to – I still wanted to take advantage of the background that I had in science. So I thought, well, I really still would like to keep working with scientists. As you probably know from your program, they're creative and interesting people. So I then moved more into the realm of science communication. Yeah. And I ended up being very lucky to work with a group. Well, you might not think it sounds so lucky, but I worked with a group that specialised in metals manufacturing. Mm-hmm. So I, moved from the sort of pure research side of things more into the engineering. And what I discovered, though, was that I loved it, because the metals manufacturing group, it was a cooperative research centre. So they were working directly on problems that were of relevance to industry. And our industry partners were really hands-on. And it was really rewarding to see how our researchers' work was being actually used on production lines, and in some cases in very impressive ways, in aluminium smelters, carrying around kilograms of molten metal in these dangerous situations, making them more safer and making the product better. And so I guess I was a bit hooked from then in bridging that gap between research and its application. Mm-hmm. And I moved from there more into research commercialization. And I suppose it was from that experience where, in that case, I was fortunate that I actually moved away from the physical sciences and engineering and more into the social sciences, which, again, I find completely fascinating. The range of interesting problems that our social scientists are working on is just truly incredible. And so too are the industrial applications of that work. And I guess at that point I got quite an interest into disruptive technologies and the impact that they could have on society. And I was fortunate enough, my sister has actually been in the field of robotics for some time. She's come at this from the perspective of human-robot interaction, and she's now in the US. She's the managing director of a company called Silicon Valley Robotics. They represent startup robotics companies in the States. It's an association that was created by a few successful robotics companies there who want to give back to the new robotics companies coming into the market. And she's been saying for years how important robotics is and how, it really is something that everybody should know more about. And being the younger sister, I kind of really wasn't very inclined to listen to her very much. But then an opportunity came up for me to work in robotics, and I really didn't have to think about it twice. It combines so many of the things that I'm most interested in, disruptive technology, the impact that's going to have on society, and having the opportunity to work with highly intelligent, creative people. What could be better than that?
Like, it's really an open slate, right? Like the history of robotics, it is quite a bit in movies, but in practical everyday, like a consumer level, home level, outside a factory setting, is very limited. It's just like the last few years. So there's so much to do in that area.
Yeah, it's exactly. I think I could have moved into robotics too early, because I think robotics has been pretty disappointing up until now. But we actually are reaching
AI like that. Yeah, similar to AI.
We are actually reaching the tipping point now where our computer processing power is at the point where robots can interpret information in real time, just using their onboard processing power. That makes them very powerful machines that can operate out into the real world, doing things that can assist us enormously. And I guess the reason, obviously a lot of people have concerns about what this means, having more robots out in the world. But the reason that I go to work every day, and I believe most of our researchers do, is because we see the potential for robots to, I guess, give humans the opportunity to expand their own potential. If we can do a lot of routine tasks by using robots and free people up to do more creative activity, or to use robots to create things from a completely different perspective that we haven't been able to do before, then I think what we're really doing is unlocking human potential.
Yeah.
And anyway, it's a really exciting place to be.
Yeah, you are at the forefront of something that can change life as we know it. I think it's something similar to the internet, like the early days of the internet, where it was quite boring and limited applicability back then. Large companies, large organizations would have an interest in those things. And then 20, 30 years later, it's totally changed how we live. We actually can't live without it. Do you think that, say, in 20 years from today, a similar effect or a similar change in lifestyle dependence on technology will have occurred thanks to new robotic technologies and artificial intelligence, say 30 years in the future?
Yeah, definitely, but I don't think people will even think about it. So just as our children now will grow up and that they can figure out how to use an iPad probably quicker than they can figure out how to walk, we'll find that the next generation is growing up with robots in their home, and they don't even question the fact that they have, at their fingertips, rich sources of information about the world around them, and a huge processing power to help them interpret that information, and probably it'll just be taken for granted.
Yeah. All this power, I was thinking that all this power is really available right now with a little bit of work. So I'm building a new quadcopter myself, and I found on the internet, a friend told me about it, that it's possible to connect your quadcopter flight controller to a Raspberry Pi. And the Raspberry Pi uses a little camera, it's a high definition camera, and in it, it's got software that makes it possible during flight in real time for the quadcopter and its Raspberry Pi to optically recognize targets. So like, for example, the owner of the quadcopter and then the drone to automatically follow that single person among a crowd of people, right? So that's pretty cool.
So what is it using for that?
OpenCV, I think, and a few
Okay.
other bits and pieces written in Python,
Yeah.
right? Which is a high-level programming language that kids learn at schools. So, I mean, the barrier is not that high anymore for these technologies. A lot of pre-written software makes all that possible. So I think we're there.
So at the Centre for Robotic Vision, are you doing any research, or are you the adult supervision?
I'm not sure I like to use the term adult supervision, but the way I like to talk about it is that I put together the framework that enables our researchers to do the work that we're trying to do. So, no, I don't get to do hands-on research and too much of the coding, but I do bring income into the centre. You know, we were fortunate enough to get the Queensland government to fund a program in social robotics that I'm really passionate about. So making those sort of things happen is what I do.
Okay, so you get to see a lot of what's going on inside the centre. What is exciting you the most?
Oh, that's like asking me to choose between my children, Marcus.
Okay, well,
How can I have a favourite?
I guess putting things into perspective, we've got things like...
What's the latest gadget that you're playing with now, for example? Something that is...
Well, not even out on the streets.
It's not out, but it's showing promise right now, if you're allowed to tell us.
Yeah, well, can I give you two examples?
Yes, please.
So our medical robotics researchers are doing a lot of work looking at how they can help orthopaedic surgeons. In particular, they're looking at a surgery called knee arthroscopy, which is Australia's most common form of surgery. And I guess some of the issues with knee arthroscopy is actually how much better the patient is after they've had the operation done. Typically, you'll have a knee arthroscopy if you might have had a sports injury and you damage your cartilage. So the surgeon's job is to go in and try and remove the damaged cartilage. They do this by keyhole surgery, but it's actually a very labour-intensive. In fact, all orthopaedic surgery is actually pretty tough on the surgeon. They're having to manipulate a large limb. They're holding a camera. They're also holding a cutting tool. They'll be operating the cutting tool with a foot pedal. At the same time, they can't even really look at your leg and they're trying to maneuver your leg into the best position so that the camera gets the best view of the cartilage, because it's, as you can imagine, your knee, it's a very confined space. And at the same time, they're watching all of this on a computer screen, not even actually able to see where their hands are. So we're looking at a couple of different things that we can do to help, whether that's a robot actually holding the camera, whether it's developing cameras that are small enough to go on the inside of the human body rather than at the moment they're on the outside, which means that you actually have to have quite a long, rigid piece of metal to bring the light and image back up into the camera. But if we use little tiny disposable cameras, then we can use a snake robot, which, you can just rotate very with minimal movement so that you can change the view that the surgeon is getting. And all of these techniques are not designed at all to replace the surgeon, but just to help the surgeon be better at what they're doing. Because eventually surgeons actually lose their dexterity and, we lose a lot of the valuable knowledge that they have because it becomes harder for them to physically do their job. By applying some of these robotic vision technologies, then we would hope that we'd be able to extend the life of practical life of these surgeons, but also make the surgery potentially quicker and more efficient.
Right. Yeah, so robotics in medicine, especially in surgery, has got a lot of potential there, right? For surgery, microsurgery, distance surgery, so the ability to operate on a patient from thousands of kilometers potentially away.
Yes, and for Australia, obviously this is of huge importance. We can't provide the remote services that our country people need, and we need to find solutions to that. In fact, I'm not sure whether you would have heard of it, but QUT, which is where our centre is based, works with CSIRO to do something called the UAV, Unmanned Aerial Vehicle Challenge. And the challenge next year is to do something that they're calling the Medical Express, which is where you have to send your drones out and actually get them to either hover or land and collect a sample and then be able to bring that back to the base. This is quite a big step in the way that unmanned aerial vehicles work, because you're going beyond line of sight, and the technical difficulty of actually being able to hover or land safely near a human is a challenge that hasn't been overcome yet. But it's critical, if you consider the provision of medical services out in remote communities, that we be able to find effective means that we can potentially collect a blood sample for analysis, or perhaps deliver vital medication. We need to solve this challenge.
So now we're talking about long distances, right? It's not like down the street. It's hundreds of kilometers.
Yeah, potentially, yes.
Yeah, so that is definitely a challenge. Yeah, I'd like to switch our discussion a little bit to discuss yourself as a superstar of STEM by Science and Technology Australia. Can you tell us a little bit about that? Is that an award, or is it like a rank that you have? How did you achieve that, and what does it mean?
So you mean a rank like, you can level up?
Yes, exactly.
You go through various stages
you become
until
a superstar
you be a superstar. Well, this is a new program that Science Technology Australia have put together with the support of the federal government, and I'm one of the first 30 female practitioners of STEM to be selected to be part of the program. They're actually expanding the program in the future so that in the next year you'll see another 60 superstars of STEM. But the main aim of this program is to get greater visibility that there actually are women working in STEM, because if you really were to go from the media, you would probably consider that maybe there aren't very many women involved at all. So just give you a couple of examples. On Twitter, 92% of the most followed scientists are men, and only 11% of the news stories in the mainstream media quote female scientists. Mm-hmm. And often when female scientists are quoted in the media, we're often described by our looks rather than by our achievements.
Oh.
So we've got a long way to go to try and change the public perception that science is all done by, white-haired guys in white lab coats with, clunky glasses. That seems to be a very persistent stereotype. Yeah. But unfortunately, what it does is it holds our younger women back from pursuing careers in the area. And the reason that we have to stop that from happening is very important. For example, in robotics, we probably have less than 10% women, and yet I've explained to you how exciting the area is. Yeah. We're developing technologies that literally will change the world, and yet they're being developed without the involvement of representatives of 50% of the world's population. And we really need to make sure that we solve this.
The thing about robotics is that it's more than just technology and automation, right? Especially robotics that are supposed to be active in a social environment.
Yes, exactly.
So I'm thinking that's where a more appropriate representation of the population in which those machines eventually will be operating would be something that we all want to have.
Yeah, exactly. And I think the other misconception that people have about robotics is that you have to be a mechatronics engineer to make a contribution in robotics. Mm. My sister, as I said, she's the managing director of Silicon Valley Robotics. Her background is in the arts. My background is in the physical sciences. We desperately need people who are good at design for exactly the reasons that you've just described. There's no point in us building robots that people refuse to use. So we need to have people from a range of different disciplines, social sciences, for example, so that we can actually study the impact of robotics to make sure whether we're implementing robots in the right way or whether there are different ways that we could be implementing them. And I can tell you a bit more about our social robotics program if you're interested. I think that's the direction that we're going.
Yeah, I'd like to know, as a superstar of STEM, what do you actually do? I suppose you are an advocate, or do you operate as a mentor perhaps to girls that are interested? Tell us about that and what your role is as a superstar.
Yeah, we do all of those things. We both get mentored and we mentor other people. We try and support other women who are already in STEM, but our role is to try and raise our public profile so that people can recognise that there are women who are having an impact in different areas, so that hopefully that would mean that we will encourage people to think about sticking to studying science and maths when they're at high school and consider doing that as a subject when they enter university. So we're also committed to visiting some of our local schools, and most of the superstars, we get quite a lot of requests for public appearances as well.
Could you tell us some perhaps stories of, say, high school students or elementary school students that you helped get into science and technology later in life? And I don't know how long you've been doing this, but just some stories from the field, I suppose.
Yeah, I've only been a superstar for 6 months now, so I can't really give you
We want quick results here.
from cradle to grave examples of people that I've influenced. But I have had the opportunity to talk to, and I guess I'm always very humbled by the number of exceedingly bright female high school students that are passionate about changing the world, and many of whom see robotics as a potential way to achieve that. Have I been able to help them? I'm not so sure. I think the main help that I can give is just to demonstrate that, it is possible to stick it out and contribute in these fields. It's not necessarily easy for women, but the alternative for us to stand on the sidelines and not participate and not be involved is, I think, much worse. I think we need to actually be much more forthright in pushing forward and having an influence in the technologies that are being developed, whether that be in robotics or whether that be in any field, and making sure that we're contributing.
Is it just science and engineering where women are underrepresented? We're looking at politics, for example. It's pretty bad. When you look at the various parliament houses, not just in Australia, but around the world, in business as well. The latest ABC survey on women running top Australian companies was pretty bad as well. It seems to me that it's not just in science and technologies. It seems like it's a more widespread phenomenon.
I don't know if you can say that in politics anymore. I think with the Labor Party, didn't they just get women as the majority now for the first time ever?
In Tasmania?
I can't remember.
Yeah, I believe in Tasmania they've got a pretty crazy...
Oh, yeah, it was Tasmania, wasn't it?
Yeah. I mean, crazy. Unprecedented, right? Yeah. So there's more female MPs in Tasmania, surprisingly, than ever before. But I hope that continues rather than being a blip. But what do you think, Sue? Is this like a general phenomenon, in particular, like in a Western society, like a liberal, open, free market, advanced? I would really be expecting a lot more.
It is a general phenomenon. We are the creations of our culture, but I think the example that Marcus just gave with the Labor Party in Tasmania shows that it is something that can be overcome. I think compared to other countries, Australia is not doing so well. We can be doing a lot better, and we really need to look at those examples of companies or political parties who have made a concerted effort to make sure that they're being more representative. For example, BHP has actually stated that by 2025, they would like to have a gender equal workforce, 50-50 men and women. And they're taking proactive steps to make that happen. So, for example, they used to only have, in some cases, 0 women in their maintenance teams. And they actually went about a process of recruiting outside of the area, because clearly if there's no women already in the field and you keep trying to recruit from within that, you're not going to change the situation. So they looked at what the skills were that were required and went out searching for more diversity, and have actually been able to increase the level of female participation in their maintenance crews up to 40%. So with enough investment of time and energy, it's possible to change. I think, unfortunately, some people don't want it to change. And, that is just an ongoing issue that we have to face. But I think that STEM is worse than a lot of other areas. I mean, it probably is on a par with the challenges that women face getting into those top-tier companies. But unlike those top tier companies where, they rank in the hundreds, we're talking about millions of people. So there's 2.3 million STEM qualified Australians, and only 16% of them are female. And only 7% of Australia's engineers are female.
Yeah, that's the numbers speak of themselves. Well, do you think it's like a societal problem? Is it a institutional problem? Is it, background, education? Or is it just all of those things together in some weird combination?
It is all of those things together. And I think you can break it down, though, and make differences in all of them. I think that in general, we have quite hostile environments for women, in particular in engineering. And I see it when we often are showing people around the lab, the immediate sense a lot of women get as soon as they walk in there of feeling that they're different, that they're other, because they're so outnumbered. And I think on some level, some very basic level, that's enough to put people off. Yeah. And so, again, that's the reason that the Superstars of STEM program is so important. I think that at the moment it really is very determined women that stick with occupations that are extremely male dominated, and it's not made particularly easy for them in those environments either. So somehow the culture has to change. But I think there's also a lot that we can do at the education level, because we know...
Yeah, I was about to say.
We know that girls are interested in STEM up until around the age of 11, but then their interest starts to drop when they hit about 15. And that's at the age when they're starting to think about what careers they're going to start shaping up for. And while we are heading into an era where people are going to have multiple careers, I can't stress the importance of getting a good background in science and maths early. I think it's like learning a language. It is much harder to do when you're older. And if you've got it when you're younger, you've always got it. It doesn't go away. So...
Oh, no, it goes away. I can tell you that right now. I've forgotten so much.
Go back to school.
I think it's easier to pick it up again if you've got that background, though, than if you have, for example, if you shy away from maths. I think it makes it progressively more difficult to dip your toes back into the waters as you get older. Whereas I think there are a lot of things that you probably can pick up a bit later in life. If you decide that, you're not at all interested in science and maths and wanting to do something completely different, then I'm sure that opportunity is open for you. But with science and maths, particularly in terms of the impact it has on the undergraduate degrees that you choose, I would really be leaning towards seeing those as compulsory for everybody. The other thing that we know happens is that, unfortunately, and this is true at schools as it is at universities, the way that science and maths is taught has been influenced by our culture and is done in such a way that in many circumstances it's not very female friendly. And so I can give you an anecdotal example of that.
Absolutely.
My Year 9 daughter was looking at what her study options were and was interested in doing technology, and her friends told her that she wouldn't like it because it's boring. Now,
Great.
To try and unpack that a little bit, I could probably see that perhaps the way that the course is structured is quite possibly boring for a female student, and that we don't often examine our curriculum as to how much it is embraced by different genders. What I'd really love to see is that we publish the numbers of girls and boys that study maths and science at different schools, because I'm sure what we would find is that some schools do it in a way that is much more inclusive than other schools, and we can learn from that. So I mentioned Grace Hopper, who was the founder, who invented the COBOL programming language earlier. And you might be aware that every year in the US, there's something called the Grace Hopper Celebration. It's the world's largest collection of women technologists. And the Grace Hopper Celebration is run by a group called the Anita Borg Institute. They have a number of different programs that actually help to unpack the I guess, the gender lens that sometimes shapes the way that our education material is given to women and men. And they've got notable successes at places like Harvey Mudd College in the US, where they've managed to increase the enrolments of women in computer science from 10% up to almost 50%.
How do they do that?
What they do is they completely redesign their curriculum. They make it a lot more based on, I think, the application of the technologies, and they completely unpick the program. But there are a lot of resources on the Anita Borg Institute website, and universities can actually sign up to this. I don't believe any Australian universities have, but I think that it's something that both Australian universities and Australian high schools should be investigating with a lot of urgency. Because, to be completely frank, 20 years ago when I did my PhD, we had 50% men and 50% women doing our PhDs. And yet of the people that I went through that course with, perhaps one woman still remains as an active researcher in the area. And, the rest have just disappeared. If I go to an earth sciences or a mining-related conference, it's like a desert for women. Despite the fact that we have, encouraged women in a number of different areas like medicine, like earth sciences, to the point where we have gender parity, we're just not getting any traction in those women moving up the ranks. And that's just not right.
So if I understand right from all this, it's those high school years that seem to be the point where women drop off the science and technology curricula or the radar, and they choose to do something else.
Just thinking about my own time at university, where there was one woman lady,
yes, of course,
in my engineering.
My year was the same. So, in other words, we need to be very careful as teachers, parents, policymakers on how we can structure our curricula in those 3 or 4 critical years, right?
Yeah, exactly. I mean, some people do speculate that it happens even earlier, at the end of primary school. I don't know the answer. But what I do think we could be doing is actually keeping track of the numbers of men and women or girls and boys who are studying subjects at particular schools, because I think you would find that there are school differences. And if we were to share that information, then we could find out what the best practice is in making sure that we retain women in those areas. Yeah, I think it's a very important thing. You've probably heard of something called the SAGE program.
No, actually, I haven't. If you could tell us about it.
Okay, it's SAGE stands for Science in Australia Gender Equity, I think. I hope I haven't got that wrong. But essentially what it is, it's a reporting requirement now that universities sign up for, so that they actually report on the number of female academics and male academics that they have at various levels, so it can actually be open to public scrutiny. And, what we do know is that in a lot of areas, it might be even when women first enter into the academic system, but by the time you get to senior levels, most of the women have disappeared. But what it does do is it gives women the opportunity to actually have a look at which universities are best at retaining their female staff.
Oh, great. Yeah.
And then you have a choice to go somewhere that is likely to be more inclusive and supportive of your career aspirations. So I guess what I'm advocating is that we do something very similar at high school. I think that parents have the right to choose schools where their daughters will not be disadvantaged in science and maths.
I was wondering, how things are. Societies change slowly. We can't expect an overnight change in how schools operate, for example. So I was wondering, are there opportunities for girls at that age to engage with STEM, perhaps events that the parents can take them to, or groups that they can participate? It could be online or offline. So my thinking is that instead of waiting for the system to change to align ourselves, with things that are happening right now and make sure that girls that are interested in STEM when they are 10 years old will still be interested in science and technology when they are 15 and 20.
Yeah, I think there are a lot of opportunities. So Catherine Ball created a group called She Flies, which is a national program that encourages girls to learn how to operate drones. And then there are girls who code. There's robo-gals that come out and give demonstrations at local schools. There's a Ruby on Rails group.
Fantastic.
There are a number of different resources.
Marcus is very happy about I think it's called Ruby Girls, Marcus.
Mm-hmm.
Yeah. So the advice there is that, yes, there are lots of opportunities outside of school for girls to engage with science, technology. It could be programming, it could be robotics, it could be outdoors activities like flying drones. So just Google things around. We're going to have a few of those as well in the show notes for people to look up, but it's just one Google search away.
I think that parents do need to be very careful about their daughter's first introduction to some of these things, though, in as much as, on the one hand, we're raised to believe that, girls and boys are treated exactly the same, but, in reality, that's not the case. And I think sometimes with some of these programs, if you take your daughter along to something and they end up being there in a room full of boys that maybe have known one another for quite some time, who have been going along to, a particular coding club for some time, then it's very hard for your daughter in that situation to feel that they belong and that it's something that they should be interested in. And if you don't actually help to make sure that that first introduction is good, then it actually could set you back some way in trying to encourage your daughter that it is an activity that she should be interested in and that can be inclusive for her.
Yeah, so you got to be careful, obviously. So do a bit of research. There are activities, just be selective. The first one that you find is not necessarily the best one. Suppose you also need to take into account your daughter's preferences, interests. So if she's interested in programming, perhaps don't do mechanical engineering, at least not as the first attempt to go out and do something outside of school. So take that into account.
Yeah, I think that people shouldn't shy away from going to girl-only things. There is a reason they exist, and does make it a more supportive environment for young women. That's not to say that, once people are really super keen on something, that they shouldn't just be part of whatever it is that they want. But in the first instance, when you're trying to make sure that you don't dim that excitement, probably be careful about how you introduce those new activities.
Yeah. Discuss first. So I'd like to ask you a question that I've never asked anyone else before. I came up with it yesterday.
Okay.
So the question is this. Now, imagine that you could communicate with your 10-year-old self. So a bit of time travel happening here, but we can make it totally hypothetical. Don't worry about the spook factor either. What would you tell your 10-year-old counterpart about things that you know about today? And that could be anything, science, for example, opportunities on how to live a meaningful life, the challenges that you had to deal with as you were a woman in STEM and then in senior management as well. So what advice would you give to your 10-year-old self?
I'm not sure my 10-year-old self would have understood this advice, but I would tell my 10-year-old self that it's not a meritocracy and that you can't expect through hard work and natural brilliance to get where you want to go, that you really have to work a lot harder on your social skills and making sure that you have other people on your side if you really want to get ahead in life. And that I think that we're often seduced by the idea that if we just put our heads down, work hard, and shine in our own way, that other people will recognise this and that somehow we'll be rewarded. And I think in a certain respect at school and at university, that's completely true. You could go through school and university without talking to anyone else, just knuckle down, do your exams, get good marks, and you'll probably get rewarded for that and recognised, maybe even get a university medal. But that's not going to help you when you get out into the world of work, because that's not how the world operates.
So I was wondering that's actually good advice, not just for like a 10-year-old girl growing up. I say the same things to my kids. I do have a 10-year-old boy and an 8-year-old boy. And I do tell them, you got to work hard, but that's not enough. You need to be good with people as well, right?
Exactly.
What do you think, Marcus?
Yeah, I'm just thinking about the lessons that I teach my son. One of the things he does is constantly forget, or he plays this boy over here. He's my best friend, but he doesn't know his name. And so it's just basic things like you need to know what people's names are. Mm-hmm. People's names are like honey in their ears, and they will like you more if you are able to use their name.
Yeah. So social skills are so important, but being a woman as well, I think there's an extra level of difficulty as I see it. Like you have to be brilliant in your work, whether you are like a CEO or a COO of a company, whether you are a chief scientist or engineer, like you really, really need to be good at all that, plus a lot more. Right, yeah. So thank you for that, Sue. I also wanted to, just mindful of all the time as well, I want to go back to where we started our discussion and talk a little bit about disruptive technologies, because I know you're good at that. Could you tell us what is a disruptive technology and how does it differ from other types of technologies? And as a manager yourself and a leader in that area, what kind of attributes a leader of a team that is working in that disruptive technology world?
Do we want to be disruptive? I guess coming from a Silicon Valley background, we've got to disrupt this, we've got to disrupt that.
It sounds like there's a lot of mess and damage with disruptive. So,
well, there is.
Could you talk a little bit about that, please?
Yeah, perhaps disrupt isn't the right word, because I think it does have negative connotations, that you're breaking things that perhaps you didn't necessarily want to see broken. But at its essence, disruptive technologies are ones that our current business models aren't set up to cope with. And that disruption can be good or it could be bad. Usually it is good for the consumer, but it can often be bad for existing companies who can't adapt their business models to change. And, obviously the example that most people would use to describe this is the disruptive effect that Uber has had on the taxi industry.
Yeah, Airbnb in the hotel industry and so on.
Yeah, and, the disruptive technologies are ones that we don't actually just have ready-made industries waiting to take them on board. They're going to be technologies that we will see whole new companies and whole new business models develop around. For example, in robotics, eventually we might get to the point where you have robot-to-robot marketing. We might have people out of the equation altogether. You can completely rethink how a lot of our everyday activities are done, and that really is what distinguishes a disruptive technology from other new technologies.
Yeah, so changing industries. You mentioned Uber. Uber is very interesting because not just a taxi company, right? It's an artificial intelligence company. It's a self-driving company. What else are they?
Well, they have Waymo now, right?
Waymo.
So the computer vision company.
Yeah. So disruption is just, I think it does destroy an old way of doing business or providing a product or fulfilling a need in the market and in the society. And it's also got that element of, I don't know where it came from. It's like unexpected, right? Like digital photography is another example. So in terms of leadership, like in your position, I believe that you are in this space. What kind of skills does it take for a leader to be a good leader in a disruptive team, or disruptive technology, or a company that is in this space?
It's to always keep the big picture in mind. I think it's difficult if you get bogged down in the everyday annoyances, I suppose, of trying to get things done. The way to keep everybody motivated and focused on what needs to be done is to keep painting that big picture, and if at all possible to expand on that picture so that people can really appreciate the magnitude of the influence that they as individuals might be able to have in making the world a better place.
Do you even know what the picture might be, or are you painting it as you go? Like, you have a clear picture of where you want it to be, where the product needs to go? And
yeah, for robotic vision, it's pretty broad because it can be applied across all sectors. And so it really is a matter of where you draw the line. But I didn't mention about our social robotics program before, so I might use it as an example.
Yeah.
What we're trying to do with social robotics is we're looking at a humanoid robotic platform that is designed to be a social robot, which means that its main function is to socialize with people. The benefits of a social robot are that people actually respond to what they call embodied technology like a robot more than you would respond to a program or an app on your phone, because it looks like a human. So you engage with it in a different way. And the power of that is that we can use social robots to help us in public health education, for example, to encourage people to make healthier lifestyle choices. But we can also use it as a companion, but also as a way of monitoring patients and supporting our medical staff. So we don't have the technology quite there yet, but what we're hoping to achieve is get to the point where these social robots can navigate and find their way around, for example, an aged care facility, and can really help the staff who are working in that facility. We know that people who are in aged care homes, on average, they get 88 minutes less care per day than is recommended. That's every day.
Yeah.
So we think this is an area where the use of a social robot could really help staff and the residents of these homes. But we still are trying to develop the technology to make this happen, because what we want to have is a social robot that can find its way around, would be able to look into someone's room and then make intelligent decisions such as, okay, I can see the curtains are closed. Maybe they're having a nap and they wouldn't want me to disturb them. Are they lying down?
Mm-hmm.
Are they in bed? Are they lying down on the floor? Well, if they're lying down on the floor, that's a problem. I'm going to need to find someone to bring help. Oh, hang on. They've got the curtains open. They're sitting up in bed. It looks like they might be having their lunch. I'll go in and I'll say hello. I'll keep them company. I'll check that they're actually eating their food. I might also be able to check, are they taking their medication? Oh, with this particular patient, I know they particularly like, reading this poetry. Maybe I could read that to them. Or maybe I could remind them about the message that their doctor left for them this morning about how they have to take more vitamin C. Whatever it is, you can imagine that once we get to that level of what they call visual learning, where the robot understands enough about its environment to really make intelligent decisions, then we can really support people who work in aged care homes, the residents of those aged care homes. And you can imagine this applied to other industries. There's so much that we can do if we were able to get to the point where we can get the technology up to that level. So in terms of painting a picture, that's the sort of picture that I like to see painted. We can clearly see where the benefits of a technology like that could lead us.
Yeah, it's very interesting because I believe there's research showing that humans, whether they're older or younger, doesn't matter. It seems like it's across the ages, actually respond very well to humanoid robots, especially robots that have a face, and they can start having conversations with them and basically relate to them. I know in Japan, because of the aging population, there are robotics that are used to look after elderly starting to become common. They're doing a lot of research in that area. And also in education, we had a guest a few weeks ago who was telling us about how they're doing research in robots in the educational environment, basically to help students one-on-one, to deliver a lecture, perhaps, to help them with assignments and so on.
Well, there's a reason that robots are quite popular for people to confide in, and that is because they're non-judgmental.
Mm-hmm, mm-hmm.
If you are trying to encourage someone to eat less sugar, for example, if a person goes to their dietitian, they might feel quite embarrassed and ashamed to admit that they haven't been able to keep up with their program. But a robot doesn't care. A robot's not going to judge you or make you feel, that you've failed because you haven't been able to do something. So for a lot of people, it's much less threatening to talk to something like a robot. And the other advantage that a robot has, and this is something I think is quite exciting for teachers to consider, is that robots are endlessly patient.
Absolutely.
So you can imagine having a robot assistant in a classroom, and every day when the students go out to play outside, rather than the teacher having to remind them, you could have the robot actually visually recognizing whether they have a hat on and pulling them up if they do or if they don't. So rather than the teacher standing there going, don't forget your hat, don't forget your hat, don't forget your hat, don't forget your hat, the robot can do that, and the robot can keep doing it all day. It never gets tired. It never runs out of patience. It can take away a lot of the, I suppose, anxiety of some of these tasks that really do we need to be wasting teachers' time by getting them to be relaying that message time and time and time again.
Yeah, the robot will achieve its mission and its objective no matter what. It's not going to give up. And I was thinking also students, sometimes that they might pretend that they know an answer. They might say yes when they really say no. So the teacher will ask the students, did you understand this? We've just been talking about for 10 minutes, and the student will just say yes because they don't want to annoy the teacher, right? Where if that was not an issue, they say, oh, no, I didn't understand. Like, that's happened to me so many times. I had to go back and figure it out myself.
So, do you understand? Yes.
Yes, definitely.
2 minutes later, next question.
Great. Okay. I think we should move into rapid fire questions. Marcus, do you want to take the first one?
Yes. Well, with your mother having programmed in COBOL, What is your favorite programming language? Surely you did some programming in your time.
I am a hopeless programmer and I don't get much time to do it. I can do a bit in HTML, but that's probably the extent. It's very embarrassing to have to admit.
It's very unusual. Your mum programs, but you don't.
I'm a bit of a disappointment.
We just like to There's plenty of resources online where you can go and
Ruby girls.
So start with Ruby. Sorry about that. Okay, so I'd like to know if there are any influential people, in science, role models. Obviously, there is Grace Hopper, who is a big influence to a lot of people, men and women. Yeah, do any other people come to mind when you think about people that you looked up to?
I didn't really have a lot of role models when I was first entering into science, or at least not of the same gender. And I think at some point I just made my peace with having to, create my own path and not necessarily have a role model. But I guess the characteristics of the people that I would describe as role models, who aren't necessarily famous, but who I admire greatly, are people who have managed to have successful careers, but also balance that with having a family and actually being nice people. I think in some respects those are underrated skills.
Absolutely.
Yeah, absolutely.
No, you're right. And it's very interesting because a lot of people that are big in the media, for example, and have got the 3 million Twitter followers. And I believe that Grace Hopper would have that if she was alive today. They're very much like the people that you just described. They're balanced all around and nice people when you meet them up close. You go past that celebrity status. So, thank you for that. Now, some advice, like some more advice from you. Let's say that you've got a new teacher, goes out to school. That person just came out of university. STEM is big these days in Australia, even though some ministers seem to believe otherwise. And they will be at the forefront of the teaching profession for the next 20 or 30 years. They'll have students 10 to 18 years old. Many of them, obviously, hopefully half of them will be girls. What advice would you give them?
For new teachers?
For new teachers, yeah.
Well, I think just as their students are going to do, keep testing things by looking stuff up on Google and I guess keeping your interest in the subject alive. I think the problem for teachers is there's just so much information out there, and working out what the most valuable use of their time is, I'm sure, a very difficult situation. Finding professional development opportunities that work for the particular individual teacher is really important, but they need to embrace it because we're moving into an economy now where everyone just has to continually keep learning, and that's no different for teachers. And I think the big pressure for teachers is that their students have access to all of the same resources that they do. So the students are pretty quick to pick up on if the teacher's not on top of stuff. So that's an ongoing challenge. I don't envy new teachers going out in the field, but on the other hand, I think they have an enormous responsibility. And, I guess they also potentially have a huge legacy that they can leave behind. I know that despite the proliferation of online resources, the influence of who your teacher is still enormous because, humans are social animals. We're not robots. And we can be so coloured in our view of a subject by whether, the simple fact of whether we like our teacher or not. So I guess my advice to teachers is to never forget that. Even the kids that in your class who you hate, you are likely to be having a tremendous influence on. And there's a big responsibility and weight on new teachers' shoulders. But on the other hand, look at the amazing people that they're going to be producing who are going to go out and change the world. It's a hugely important job.
So it's both responsibility and a privilege to be a teacher. And, the times today mean that the teacher actually is also a student at the same time.
Constantly learning. Yeah. That would be the other big one.
Yeah.
So as we're running out of time, we've got to ask you any parting thoughts for our listeners, any do's, don'ts, or anything that they should look out for?
Well, I think just keep your eye on what the latest things happening in the world are. There are so many different changes that are going to be coming on us, and they're going to be coming on us very quickly. And anything that people who are listening can do to help their friends and neighbours to adjust to the coming technological changes is going to be really important. And it's really important for Australia because our competitiveness really relies on us being able to keep up with the rest of the world and, in fact, lead the rest of the world in some areas. We can't really afford to slow down. And that pace of change is going to be really uncomfortable for a lot of people, and it's potentially going to be uncomfortable for society in general. And I guess we just have to not lose sight of the many benefits that are going to accrue to society as a result of these new technologies. It's important that we're not afraid of them, that we invest some time in understanding them and making sure that we learn about what's coming up next.
Yeah. Suppose technology is coming whether you want it or not, right? It's not something that is reversible. I thought you were going to say, beware, the robots are coming. But personally, I just can't wait. I want to have, a robot assistant here in my lab.
Well, their brain is here already, I would say.
Great, thank you, Sue. So I think we reached the end of our podcast here. So do you mind if people get in touch with you?
No, that would be fine.
If you don't, how would you like them to do that? Email, Twitter, Facebook?
Sure, my Twitter handle is just Sue Keay, Suekeay. So feel free to get in touch.
Awesome. Well, thank you very much, Sue. It was a pleasure talking to you about a lot of very interesting topics.
Yeah, thank you, Peter. Thank you, Marcus.
And wish you good luck as well as you spread the word as a superstar of STEM. I think you're doing a great work there.
Thank you.
Great job.
Okay, bye.
Bye-bye. That's all for this episode. The notes for this episode that include links to many of the resources mentioned and information on how to get in touch with Sue are available on our website, texplore.com/pay/Stemiverse. Each episode comes with its own page on the Tech Explorations website and a goldmine of information in the notes. This Stemiverse podcast episode was produced by Tech Explorations. Do you have any questions or suggestions? Would you like to nominate a friend or colleague to be our guest? Please email us at pa@texplore.com. Subscribe to us on iTunes by searching for the name of our podcast, Stemiverse. That's Stemiverse. Thanks for listening, and we'll see you again next time.